A very good afternoon to everyone who has joined on our virtual platform. Little Flower College welcomes you all to this international webinar on Future of Telecommunication Technology with 5G. Today's webinar session is organized and hosted by the Department of Computer Application, Little Flower College, Guruvayoor, and myself, Ria Jacob K, Assistant Professor at Department of Computer Application. We are really proud to host this international webinar on the topic Future of Telecommunication Technology with 5G. On this day, we are quite lucky to have Mr.Salil Gopal, Telecommunication Technology Consultant and Senior Technology Lead at MS Telecommunications, RMIT, Melbourne, with 14 years of experience in the telecommunication industry. So, we are very much fortunate to have such a prominent individual in this field as the resource person of this day. The session is also enriched with participants from various parts of India, Bahrain, Qatar, Australia. To officially welcome the gathering, I welcome Ms. Simna Vijay, Assistant Professor, Department of Computer Application. Over to you, Ms.
Good afternoon, all. Today, we are all here for an international webinar on topic Future of Telecommunication Technology with 5G, organized by Department of Computer Application. First of all, on behalf of Computer Applications Department, I welcome our resource person for this webinar, Mr. Salil Gopal, Telecommunication Technology Consultant and Senior Technology Head, MS Telecommunications, RMIT, Melbourne. Welcome, sir. I extend my hearty welcome to our dear principal, Reverend Sister Dr. Valsa M.A., who is the backbone of our institution. Welcome, sister. Next, I welcome our coordinator and strong pillar of our department, Dr. Sister Marina A.A. Welcome, sister. Last but not least, I welcome everyone who is present here for this webinar. Once again, welcome all. Thank you.
Thank you, Miss, for that warm welcome. Our college principal, the Reverend Sister Dr. Valsa, is a capable leader with a bright personality who constantly guides and supports us in achieving our goals. I would like to welcome the Reverend Sister Dr. Valsa M.A., our esteemed principal, to formally inaugurate the webinar session and offer the inaugural message. You are welcome, sister.
A pleasant good afternoon to one and all. Joyful greetings from LF family to all the participants. Today's generation is eagerly discussing about innovations with the 5G and looking forward the revolutionary changes in the field of telecommunication technology in the near future. In the present scenario, COVID-19 created a generation within 4 walls of cell phones, and this led to good and creative impacts in the globe. In such a situation, today's international webinar is more relevant and significant. First of all, I took this opportunity to congratulate the head of the Department of BCA, especially Ms. Zavia and Ms. Lisna Zimna, for their initiative to conduct this international webinar on Future of Telecommunication Technology with the 5G. Our chief guest, Mr. Salil Gopal, Telecommunication Technology Consultant, as a resourceful person to enlighten the brains of our young and energetic students of Little Flower College. I wish a grand success to this program. I declare the webinar is inaugurated. Thank you.
Thank you very much, sister, for your warm thoughts. Before we begin the session, I would like to take this opportunity to introduce you the day's resource person, Mr. Salil Gopal, a consultant and senior technology lead currently working at Telstra Corp to build monitoring capabilities on the 5G network. He manages a DevOps team who operate Telstra's probes and monitoring solutions. His previous experience in telecom has been across service assurance in fixed, wireless, and transmission networks. His end-to-end role across the multiple domains of the telecommunications and business involved improving the network and product performance, security, integration, system analysis, and customer experience improvement. Some of the projects he has worked on are 4G and 5G rollout, voice over LTE project, RCS project, messaging rationalization project, transition to agile methodology, etc. He is also an accredited trainer and assessor and has been involved in planning, developing, and delivering training packages for advanced telecommunication courses for traffic. Yes, sir. We are very much honored to have you here in this virtual platform today, and we are eagerly looking forward to your talk on future of telecommunication technology with 5G. Wholeheartedly welcome you, sir, to this webinar session. Over to you, sir.
Thank you very much. I hope everyone can hear me. Is everything all right? You can
Yes,
just
sir.
raise your hands. Yep. Okay, good. Thanks. Thank you. Thank you for welcoming me, and thank you for the opportunity. I think people have given a good introduction of me. Probably I can start with my slides and start talking. Please let me know if you're able to see my screen.
Yes, sir.
Are you able to see my screen?
Yeah, I am.
Thank you very much. Okay, so future of telecommunication technology with 5G, and I've got the computer applications department hosting it. So what's the relevance? That's going to be the first question. With 5G, once you finish the slides, you'll know why computer science is going to be, or IT is going to be going to play a major part in this technology revolution with 5G. Right. My name is Salil Gopal, so I'll introduce myself. I am a telecommunication professional, and I've been working in telecommunication for the past 14 years. And before that, I did my graduation. My first graduation was in India. I did my BSc at Sacred Hearts College, Thevara, which is basically, I'm from Cochin. So after that, I did a Bachelor of Engineering from Bangalore University, and then did a master's in telecommunication from RMIT, Melbourne. So that's my educational background. And I work with a company called Telstra. I've been a permanent employee of the Telstra Corporation. And most of the time I worked with was mobile. So I initially started with service assurance. I don't know if you understand what service assurance is. Assurance is to make sure that the services are all working. So if somebody makes a phone call, or somebody sends a text message, or somebody browses the internet, they are able to get that service. Now, I've put my LinkedIn details there. So if you need more details or understand or connect with me, you have the LinkedIn details, and also my email address. If you have any questions, or you have any queries, or you want to know more about, and you want to know where to look for more information, I'm happy to take them on. You can send me an email or connect with me on LinkedIn. Um, Now let's move to the agenda for the day. Now, things that when I was preparing the slides, I probably had very short notice to prepare these slides. I put together some details that might make it interesting, because I don't know the different levels of understanding of the network for the students and probably somebody else who's joining. So I've tried to make it as basic as possible so that I introduce you to the 5G network. And the first item, 3G network and 4G network introduction. I did put those two slides there because if you don't know where you're coming from, you don't really know where you have to go. So that's basically looking at what we already have. And I know that in India as well, we have moved, some of the service providers have already moved to 5G, but the service that you probably see, if you look at your mobile phone right now, it might show 3G or 4G. So probably it's a good point to start. After that, we'll have a look at the reference point representation, or the reference point representation of the 5G network. Then we will also have a look at what's the difference between 5G and 4G. Why do we need to move from 4G to 5G? Next would be the 5G service-based architecture. Now, service-based architecture is new. So I'll try to explain what a service-based architecture is. After that, we will look at what are the enablers for 5G. There are three enablers, and they are very important, and they are going to be very futuristic. Services of 5G, different services that this 5G is going to be providing. And after that, we'll have a look at the 5G network slicing, which is a new concept in networks. And we will have a look at what slicing is about. Then I'll also try to introduce you to the container services, or what is containers, and what relevance it has with 5G or telecommunication. Last point one would be the network orchestration. Basically, we'll take you through those, give you an idea of what a network orchestration is about. You will understand that, or give you a brief idea of what orchestration is. Finally, there will be a session for questions. Now, just in case you have any questions, in between the slides, please do type it into the chat, or raise your hand so that I can come back and answer those questions. Right. Are we all set? And can we proceed now? Is everything all right? Are you guys able to hear me now? Sorry.
Yes, sir.
Okay, right. Okay. Just making sure that everything is all right before I start. Now, let's start with the 5G network, and probably currently you are on the 3G network. Now, I would believe that everyone who has joined right now has got a mobile phone. Now, how many of you would know how exactly does a mobile phone work? Here, because this is a not interactive, so if you I'll give you a brief idea of how a mobile phone would work. Okay, so start from you've got a mobile phone. You walk into a shop and you buy a SIM card, right? And you give them the photo, you give them the identification, and then you come back home, put the SIM card into your phone, and then and then you wait for some time, and then suddenly you will see that you've got service and you're able to make phone calls. Now, how did that happen? What went in between? So what happens there is that when you buy a SIM card, that service operator is actually adding or giving you a mobile number, and then he adds your details onto their network. So somewhere on the network, there is a database and your number, your details of your SIM card has been added, right? And then when you connect your network, they know exactly who you are. And that's how you connect to the network. Now let's start with the process. How do you connect? Now you've got your SIM card inside your phone. Probably take this pointer here. Now you've got your SIM card inside your phone. And then initially what happens is that when your mobile phone knows what the SIM card is and what frequency it should be connecting to, and then it searches for base stations or node Bs. So in 3G, they're called node Bs, the base stations. And you've probably seen one of these base stations on top of some shops or probably on buildings. And then what basically happens is that there are transmitters and receivers on this base station, and that's how you connect to those base stations. Now, once you send this, so at this point of time, you've got SIM card in your phone, and the network doesn't know that you know who you are, or are you able to connect. So then initially what you do is you send an information from your phone to the network, and then from the eNode Bs, it goes down to the MSC or via the RNC. So now, what is MSC? What is RNC? Now, MSC or RNC is a radio network controller and connects the radio base stations or the eNode Bs to the core elements or the core network. So initially, let's divide this network into two. So you have the radio part, the radio access part, which has got the radio base stations and the RNC, and then you have the core part, which is the rest of the elements. So when you connect for the first time, your eNode B sends your information directly to the MSC, and MSC would look into a database, which is the HLR. Now, let us explain what MSC is. MSC is a mobile switching center. It basically does all the switching. It's like an old exchange or old telephone exchange. So it has got it also looks at and controls all the data that passes on through the network. So MSC is like a brain for the core network, right? So when you first initially try to connect to the network, the MSC would look at the details and see whether HLR has got your details. And if HLR has got your details, it replies back to MSC saying, okay, this guy has got a connection, he has paid for it, or he has promised to pay for it. And then MSC would send that information to the node B, and that information would authenticate this user. And this authentication procedure by itself has got several steps to it. But the end of this process, what you call is, it is called the attach process, or the process where the mobile phone connects to the network. And at the end of this attach process, the network would know that, okay, this guy, say probably someone let's give him a name as Rajesh, or Rajesh has actually connected to the network. But he is connected to the network, but he has not started using any service. Even if he doesn't use any service or he doesn't make any phone call, MSC and the node B will continuously monitor where he is, because it needs to know where this person is sitting, right? So he might be sitting at his home, or he's in his workplace, or it continuously monitors and maintains that connection. Now, once he needs to make a phone call, so first initially he has attached to the network. The network knows that this is Rajesh. Now, next step would be if he wants to make a phone call, right? So what he does is he takes his phone, dials a number, and that number goes via the eNode B, goes into the MSC, and then MSC is as I told you earlier, it's a brain. It actually looks at who is trying to call. So then MSC understands that Rajesh is trying to call, and then who is he trying to call? So so there's a call party and the calling party. So MSE would look at who the calling party is, and then MSE would send the signals to the GMSE, which is a gateway MSE, and the gateway MSE would be connecting you to the other party. Now, here, this operation, what you see here, it is a circuit switched operation. So you can see that I've put it as a circuit switched. So that means that if you know what circuit switch is, it's almost like you need to have a cable directly connecting these two or these from this network. You should have a dedicated circuit connecting you to this PSTN or other carrier or even the same carrier mobile phone. So this is how you make a phone call. Now imagine this person wants to make wants to browse the internet. Now what happens is that you open your browser, you type in www.google.com or wherever you want to go. What happens is that MSE again gets that information saying that, okay, this guy wants, or this Rajesh wants to connect to the internet. Now to connect to the internet, it's a data service. And MSE, similar to MSE, there's something called SGSN on the 3G network. Now, SGSN is a serving GPRS support node, which actually looks at, which is pretty much similar to the MSE, but it actually controls or sends all the, it controls the data services. Now, when he needs to connect to the internet, what happens is that he goes from the E node B towards the RNC, and from the RNC, he connects to the SGSN. Now, from SGSN, it goes into the gateway or GGSN, or the gateway GPRS support node, which is basically the node that connects you. This is basically a router that connects you to the data network or the internet. So this is how you generally connect to or make phone calls to on the network. Now, moving on from 3G to 4G. So what changed in 3G and what is the difference between 3G and 4G? Now, 3G, you will find that you are able to make phone calls, and that's going to be circuit switched. Whereas when you want to where you want to browse the internet, you use SGSN and GGSN, and that's and connect to the data network, and that is packet switched network. Now, on 4G, things change different, and things are different. In 4G, there is no circuit switching. The whole thing is packet switching. Here again, you will see that there are some similarities between 3G and 4G network. Here again, you have a radio access network and a core network. Here again, you have a EUTRAN or enhanced UTRAN, or which is the radio network, and an evolved packet network, which is called EPC. Now, it's pretty much similar. The 4G network is pretty much similar to the 3G network, but only component that you will see as missing is this GMSE, and you will see that some of the terminologies have changed. Now here, you see that instead of MSE, you have MME, and instead of SGSN, you have SGW, and instead of GGSN, you have PGW, right? And then this is PCRF. We'll talk about it when it comes to it, right? Now here again, it is pretty much similar to what you had in the 3G network, whereas there is something which is missing here. Now, what is missing here? What is missing here is the RNC. So RNC used to be, as I said, a radio network controller, which connects base stations together. You will see that the RNC is missing here. Now, what happened to the RNC was that RNC was partly absorbed by the E node B and partly absorbed by the core network, right? So here you don't have the RNC, those functions are actually done at the eNode B itself. So eNode B here, there would be a box, and then it would do part of the activity what RNC does, and a part of it is actually being given to the MME. Now here again, as you said, if you make a data call, it would be similar as to what happened earlier. Like the MSE would the MSE would send the call or send the details to the SGW, and then SGW would send it to the PGW, and then you connect to the internet. But then how do you make a voice call? Because there is no voice caller, there is no packet switching here. So to solve that problem, we have something called the IMS. Now, what IMS does is, IMS would allow you to make SIP calls or VoLTE calls. You probably heard the term VoLTE or voice over LTE. Now, 4G networks are also called as LTE networks. So VoLTE calls is what makes voice calls on 4G possible. And because this is a data network, it cannot have circuit switched or circuit switching. The call has to happen as a VoLTE or a SIP based call. Again, here another difference that you see here is that you had the HLR here. Here, the same HLR or the subscriber details or your details that you have provided, they are all stored in HSS, or HSS is a home subscriber server. It's a central database where all your details are stored. So when I say details, most of the people they think that the HLR actually stores your mobile numbers. Actually, when you get a mobile phone, for you or as a customer, it is your mobile number that is very important, and that actually distinguishes you from from the rest of the mobile users. But when you get into the network, you will understand that mobile number does not have much value. It's actually something else, which is called IMSI. It's called IMSI. And that's actually coded into your SIM cards. Every time you change your SIM card, you get a new IMSI. And this IMSI number is actually linked to your mobile number. So you can have one mobile number and you have a bad SIM or something happens or you lost your phone, you can still get another SIM card, but get the same mobile number. And those details are actually stored in the HSS. All right. Now, something else which I have tried to do here is that in both these networks, I've actually tried to use the brown lines to show the packet switching network and the green lines to show circuit switching network. Right now, here you can see that there is no brown lines. That means that there is no circuit switching at all. Now, sorry, just give me 1 second. All right. So as I said, 4G networks actually moved you from being circuit switched to packet switched. That's good enough. So if we are all packet switched, why do we need to actually move to 5G network? And this is the 5G network. There were a lot of limitations of 4G network, and that's once we go through it, I have got a slide for it, which would actually explain why we moved to the 5G network. Now let's move on to the 5G network, and this is This is your 5G network. I think somebody has got the unmute on. Hello. Yeah. Okay. So this is your 5G network, and you will see that it looks pretty similar, or the reference point representation looks pretty similar to what you had before. Like you've got something which is like boxes there, and then you connect to the boxes, and somehow you connect to the network. But this is a reference point representation, and I'll tell you why it's called a reference point. Now, in 5G network, first thing that you notice, you should notice, is that, hang on, where is my mouse? Hello, I can't see my mouse. Okay, here. Okay, so in the 5G network, a base station is called G node B, or next generation node B. And in this base station is quite different from what you already had seen, right? Why is it different? Or what is the difference? It's that it uses something called NR, or new radio, and it has got a very high bandwidth. That makes it different from what you had earlier. Now let us look at each individual items on this 5G reference point representation. First thing is the UE. You probably know this. This is your mobile phone, but your mobile phone has to be 5G capable. That means that you need to have a phone that actually works on 5G. Next item is the AMF. AMF is access and mobility management function. Now, AMF is pretty much similar to your MSC or MME. It basically looks at where you are, which base station you are connected, who you are, what is your mobile number, and what are the things that you are subscribed to. All these things are looked after by the AMF. Similar to the SGSN or S gateway, in 5G we have SMF. SMF is session management function. Basically, it looks after looks after the sessions. When you say sessions, it's basically data sessions. So it controls the data sessions for this particular user. And mind you, there is only circuit switching on 5G. There is no packet switching. Now, AUSF is authentication server. So you need to make sure that the person who is connecting to your network is actually authorized to use it. Basically, for the service provider, it means that he has paid for it. Unless he has paid for a service, they wouldn't let you connect or let you use any service. Then you have the UDM, which is a unified data management, which is basically a database which actually stores all your information. Then you have the PCF, which is the policy control function that basically controls how the data is used, what data is used, and if there is a priority for any particular data call, if there is and it also looks at the charging for how you are charged for your service. Right now, this is something which I missed to talk about, was this PCRF here. PCRF is basically policy and charging rules function. Basically, that actually determines whether how to charge you, and depending on the service, of the actual billing aspects of your service provider will be taken care of by this PCRF. And also how, like say, if you are a priority, if you're using a priority service, then you need to be allowed, and depending on if it is congested, then you make a phone call and you're calling probably the police or ambulance. Then, even if the network is congested, PCRF is the one which we look at. Okay, this guy is trying to make an emergency call. Then it would allow you to make an emergency call by probably dropping some other customer who is not making an emergency call. Right. Coming back to this again, you have the UPF, or the user plane function. This is where the actual data travels, or this takes care of the actual data flow. And you can see that I've used the green to indicate that. So this is how the data flows in the network, or this is where the data flows in the network. Now, NSSF is a network slice selection function, which basically is about network slicing, and I would explain that in the coming slides what slicing is, and this is the network element that actually would look at the slicing function. All right. So this is called a service point representation, but you will notice that in the coming slides that this is actually for just to indicate how the network looks like for easy understanding. Let us move on to the next slides, as what is difference, or what drives, why do we need to change from 4G to 5G? So this table here actually represents the differences between 5G and 4G. Now 4G is what you already have right now, and you can see, 4G is what you already have right now, and you can see that there is a lot of differences between 5G and 4G. First one is latency. Now, do you understand what latency is? Probably you have learned about latency, or you've heard about latency, and latency is actually what we call as speed. So latency is, say, for example, you have one point here and another point here, and say, for example, you are in your college, and this is the Guruvayoor temple. The time that you take to go there is latency. And most of us, probably you might have already done. You do a ping test. So if you go into your browser, or if you go into your command prompt and type in ping, and then type in yahoo.com or google.com, it would show you some time that it took for that ping message to go from from your computer to Google and then come back. That shows the latency, the time that it takes to go from one place to the other and then come back. And ping test is usually used to check on latency. Now, ping test is not just used for latency, it is actually used to make sure that one of these points is up or down. So if it is switched off, then you would not get any response back. But to tell you, latency is the time that it takes to move from one place to the other. Now in 5G, you'll see that the latency, if you have done speed test, if you go to speedtest.net, you can do a speed test, and you would say there would be an item there which would actually say as latent, which will actually tell you what the latency is. Now in a 4G, typically the latency is from around 10 milliseconds to 100 milliseconds. I mean, most of the time, if you're getting 10, it's really good. 100 means that it is a little bit slow. But whereas in 5G, the latency is less than 1 microsecond. When I say that, this is like 10 times or sometimes 100 times better than what you already have. That means that the speed in which the communication happens is very, very fast. Now, how do we get this? How do we get to that level? That is something which I'll show you in my slide on how is that possible that you can have such a low latency. The next one is the download speeds. Now, this is what we all complain about. Our download speeds are very slow. Now, these two factors, latency and download speeds, are very interconnected. Most of the time when we say download speeds are slow, it basically means that our latency is too high. Now, download speed typically for a 4G network is 1 Gbps. I don't think any one of you have probably reached that 1 Gbps speed at all. This is where we all complain that our YouTube videos, they just keep on doing the circles. Now in 5G, this is going around 20 times. In 5G, you get up to 20 Gbps. That is like too much of, like if you're downloading a Netflix movie, it is happening in seconds. The frequency channels. So these are channels that are used by the frequency or by the base stations. And in typically in 4G, they are between 20 megahertz and 100 megahertz. Whereas in 5G, they go up to 800 megahertz, and they can scale up and down depending on what is needed. Now the core network. If you remember what the core network is, this is the core network here. And in 5G, this is the core network here. Now the core network is hardware dependent. That means that all these items in 4G and 5G, in 3G and 4G, they are actually boxes from vendors. So people like Huawei or Ericsson or Nokia, they make these boxes, and we actually, or your network service provider, actually purchases these boxes, and they are totally dependent on the hardware. So that means that if you need to scale up, you need to buy a new hardware. Whereas in 5G, you will see this concept that it's cloud-based, and it has got SDN and NFV. So what is SDN and what is NFV? These are some things that I'll try to cover in my presentation today. So cloud, probably you guys have already you guys already know this. Cloud is basically an architecture where you have everything on the cloud. So you have a data center, but everything is available on the cloud. So it's not you probably know about AWS and Google Cloud and Azure, Microsoft Azure clouds. So similarly, there are other clouds as well. So this is the core network is on the cloud. It is not any service provider or exchange based. They are on the cloud. SDN is software defined networks, and that's again you define your networks using software, and you're not using, you don't have to go there and tune your hardware. It's all software defined. And NFV, or network function virtualization, is a process by which, or is the technology by which you make these happen. So we'll cover this in the coming slides. Now, subscriber density. This is very important, especially for India, because we have got a very high density of people. So the number of subscribers that can access a base station, or number of subscribers per square kilometer. Currently on 4G, it is 10 raised to 5 subscribers, whereas when it comes to 5G, it is 10 raised to 6. Now this is 10 times. Now 10 raised to 5 by itself is a big figure. Now when you consider that it is 10 times more than 4G, that means that it is much more bigger than this. Now, when you say subscribers here in 5G, you will see that it's not just people, there is going to be some other things as well. Now, what is it designed for? Now, a 4G network is designed basically for mobile broadband services. So basically, when they had 4G, when they designed 4G, they were thinking about people connecting to the internet, or it was basically just the mobile broadband. Now, when it comes to 5G, there are three things that I would probably explain. I'll explain in my in my coming slides. There are three things that come as very important. That is, one is eMBB, or it is basically enhanced broadband services. Basically, your ability to see YouTube videos, your ability to browse the internet, and share data. And something else is URLLC. This is where you have ultra reliable, low latency communication, which is basically this basically makes possible for automated cars to run our streets. Then you also have massive machine type communication, and when you say MMTC, you probably not realize it, but this is actually this actually makes IoT possible. You probably know what IoT is, Internet of Things. So your machines, they communicate using MMTC. Now, network design. The network is actually designed with the base station in the center of it. So whereas in 5G, you will see that it is more heterogeneous network, and the base station does not have much impact at all. So when you move forward, you will understand what heterogeneous network is about. So that are those are the basic differences between 5G, 4G and 5G. And from a user perspective, as of right now, I think probably what will concern you is this latency and download speeds. They're going 10 times. The latency is reducing 10 times, and the speed is going to increase 20 times. Okay, now earlier when I showed you the 5G, the reference point, you saw that there was these network elements is here, and they were all connected, and these are all different signaling that happens between these two, these network functions. Now, okay, that's something which I missed out. Like here, I told you in 4G networks, these are hardwares, right? And they are hardwares there, and these are boxes which you buy from vendor. Now, when you come to 5G, these are network functions, or they're called NF. Basically, what is an NF? It is a group or a container or containing containing microservices, and they are actually talking to each other. And when you come here, you will understand that these are these are network functions, or NF, and they contain some software which are actually communicating with each other, and that is how you make this network possible. Now, again, the whole thing is in the cloud. So as you said, there is no hardwares anywhere. These are all in the cloud, right? Now, in a service-based architecture, let's first understand what service-based is. Now, when you say service-based, you can see that these are network functions there, or you have one network function here and another network function here. And these network functions, they actually have to talk to each other, and they use the service-based interfaces to talk to each other, and then they are usually a request and a reply. Now, one of these network functions would be a producer, and the other one would be a consumer. What is a producer and a consumer? So to put it as an example, say for example, this network function is, say, like a a vegetable shop. Now the vegetable shop or a farmer, he's actually producing the vegetables, and then a consumer, say if consumer is, say, probably somebody who's got a poultry farm, right? He needs these vegetables, he sends a request and he gets the reply back, and that's how he purchases his stuff. Now when the farmer needs to buy say something, some meat or poultry, then he becomes a consumer, because he is the one who needs it now. So he sends a request, and then he gets a reply, right? So this is called the service-based architecture or service-based interface. So these are the service-based interfaces on through which they communicate with each other. So each network function is a collection of microservices. So each network function has got several microservices, and these microservices provide service operations. Right. Let's come back to this one. So here, as I said, this is a network function, and there are several microservices running in it, and these microservices actually need to contact other microservices. Then they use this service-based interface. Another aspect what you would see in 5G is that, you know, the control plane and the user plane is separated. Now in the control plane, you okay, let me explain what control plane is. Now control plane basically controls where everything controls how the network works, and the user plane is where your data actually travels, right? So if you're watching something on internet or making a phone call, the control plane actually controls where to send your data or how to send your data, and the user plane is where the data actually flows. So in 5G architecture, the control plane and the user plane is separated. Now let's move on to the next slide. Okay. Here we will discuss about what are the 5G enablers, or what is required for 5G to work. Now, when in the beginning I said most of you are computer science graduates, and how is 5G going to be important for you? So once you go through this, you will understand that that the whole 5G network is cloud native. Now, when you say cloud native, what do you mean? It basically means that you can actually have your network on the cloud. You don't need to buy, or you don't need to buy hardware. You can actually have all of your network on the cloud. Now, some of you might be thinking, okay, then what will happen to the radio component? Now, the radio component would be like your I mean, most of the compute part of your radio component. So the computation part of the radio component would be in the cloud. All you will have is something like a modem. Like when you have, I would guess most of you have got internet at home, and you would know that what you have at home is a modem, and basically just a modem, right? So the same thing The radio part would be reduced, as the base stations would be reduced to something like a modem that you can actually buy. So you basically can go and buy a base station, which is going to be like your modem, put it at home, and you would be able to use it. And that's probably going to be the future, where you would have, you'd probably can, if you don't have coverage, you can just go and buy a radio base station and put it at home. And of course, the core is already in the 5G, in the cloud. So that's the whole network. The 5G network is cloud native. Next, you see ultra dense network. 5G network is going to be ultra dense to the extent that you will find that there is um, 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 more base stations than actual users. So the concept of ultra dense network is that for you would have probably 1,000 cells or 1,000 base stations, and when you say base stations, these are going to be small desktop base stations that you can purchase and put it on your desktop. So you are probably going to see that there is going to be more base stations than actual active users. The next one is massive MIMO. Now, massive MIMO is and MIMO is multiple multiple antennae for transmission and reception. So basically what happens is that currently what you have is, on a base station you have one or two receivers, and then one transmitter. So that's how generally base stations are. But with massive MIMO, you will have a lot of receivers and lot of transmitters. So that uh, makes it, that is the concept of massive MIMO. So the base stations that you see, or the antennas that you see today, they are also going to be vanished, and you will have these MIMOs. And MIMO is multiple input and multiple outputs. Now, millimeter wave, wave, you probably heard about wave. This is the use of high frequencies of up to 20 from 20 gigahertz to 200 gigahertz. This is use of high frequencies. The 5G uses high frequencies, and these are generally untapped, and so that is how you will be able to get 20 gigahertz, up to 20 gigahertz of your downloads. Now, there is a disadvantage with waves. The disadvantage with waves is that as you increase your frequencies, your coverage actually reduces. So the amount of distance that the waves can travel, or these radio waves can travel, they get highly reduced. But that will be taken care of by this ultra dense network. That is exactly why we have ultra dense networks and more base stations, because you're going to be starting to use high frequencies, and that will give a lesser coverage footprint. MECs. MEC is about about edge computing. Now, edge computing is not a new technology. It has been there. Basically, what it does is that the compute function is actually brought closer to the user, right? So when you say compute functions brought closer to the user, basically, uh, uh, so for example, let me give you an example. Like, if you have you know that you have your laptop. Your laptop has got a processor, and the processor actually does your compute functions, right? And depending on what processor you have, your computation function, how much you can compute, or how much faster you can compute, is actually dependent on your processor, or the speed of your processor. Now, imagine if you can use the internet and connect to the to the network, and the network actually does your compute. So you can have big servers and utilize those big servers for your computation, and that makes it faster. So the solution that provides services and computing functions required by users on the edge nodes. So basically, what it does is that it makes computation very fast. A scenario would be like this. Like, say, for example, when you say 5G, and the amount of to somebody who does not know anything about 5G, just imagine each one of you probably have a corporation tap or a municipality tap that provides water to your house. Now, with 4G, what they did was they actually widened the diameter of the tap, or diameter of that pipe. But with 5G, what you're doing is you're actually bringing your water tanks closer to your house. So that's the difference, or that's what edge computing is about. D to D is device to device communication. So that means that devices using 5G, the devices would be able to communicate directly with devices, and you don't need, and that would be made possible by 5G. I don't know whether there are questions coming up. Sorry, let me just have a look at it. Or do you want me to look at it at the end? I think I'll go through the questions at the end. Okay, network function virtualization. Now, as IT or computer science students, this virtualization is probably not new to you, but what you will see here is that the network functions have also been virtualized. In 5G, the network functions have also been virtualized, or they use this concept of network function virtualization. SDN is managing networks through programming. So rather than having to manage networks using hardware or configurations on the hardware, you're going to start using programming to manage your network. Network slicing. The slicing is a concept where you create multiple logical networks using a single physical infrastructure. So what is it? I've got a slide that explains this, so that will be explained there. But what you understand is that there is going to be multiple logical networks using single physical infrastructure. And then you have the orchestration. Orchestration is a management, or the network management from an end-to-end basis. Now 5G lets you do that orchestration, or the 5G orchestration or from an end-to-end basis, or using using orchestrators. So these are the key enablers, or the main enablers for the 5G network. Now let's go into the next slide. Services of 5G. Now, what are the services? What are the different services that 5G provides? Just give me a second. Now, the first one is enhanced mobile broadband. Basically means that your data connections are going to be enhanced. That is high data rates. That's very high data rates, where you would be able to download things and upload things faster. Large data volumes. So you can download, like what I said, you can download a Netflix movie in less than seconds. And low latency, best effort. Now, for a mobile broadband, it is always best effort. You probably heard this term when you learned about TCP. It's best effort, but the latency will be much lower. The last one says FTTH FTTX alternatives. Now, FTTX is fiber technology, fiber to the terminal, so fiber to home or fiber to um, the curb. With MBB, when you get, say, something like 20 Gbps, basically you make your data connection or your wired connection. This is going to be an alternative for that connection. So basically, you can use the enhanced mobile broadband as an alternative for your FTTX or FTTN or FTTH or the next one is MMTC, or massive machine type communication. Massive machine type communication is what I said as IoT. So this is what enables IoT. In massive machine type communication, there would be a number of devices. So for example, say tomorrow your washing machines, your fridges, uh, uh, things at home, or even machines in your house, like the microwave, your pressure cooker, everything's going to start being enabled with enabled with IoT. So that means that they would be actually connected to the network. So that would cause a large number of devices to be connected. Now, because MMTC, it does not send too much of data. So if, for example, a machine at home, it would not send too much data. It would probably, like, say, as of right now, I think in Australia, they've already rolled out smart meters for electricity. So it basically, it can actually look at it can actually send the details or your usage details directly to the supplier without having him to send somebody to do a meter reading. So so things like that, there is not too much of data that is being sent. There's only very small amount of data which your electrical meter just needs to send the updated meter reading probably once or twice in a day. Or if something happens or something is wrong, only that information needs to be sent out, and that's probably just an error code. So there's not too much of data that is being sent, but it definitely needs more coverage. So MMTC would use frequency bands that can actually traverse more distances. Next one is a long battery life that it would need, because if you don't have coverage, if you probably noticed, when you're in a poor coverage, your battery actually runs out very faster. And that's because your mobile phone needs to use power to match up with the network, and so that it can actually reach the network. So here, coverage is going to be a big factor here, and most of the MMTCs would use frequencies which can actually reach long ranges. And the last one, it's actually IoT. So as I said, this is going to be a technology, or MMTC is going to be used by IoT or IoT devices. And this is in IoT is actually in the very, very beginning stages, and in very near future, probably in a couple of years, you will see that the number of devices that are IoT capable are going to increase exponentially. The last one is URLLC, or ultra reliable low latency communication. Now, there are two parts to it. This is ultra reliable and low latency. When you say ultra reliable, then you should be able to, like, it should be reliable, as well as it should have a lower latency. Now, this one of these technologies, which would be using this, is V2X. V2X is vehicle to services. So say something like you have once you start having autonomous cars, uh, it needs to have the communication should be super reliable, as well as it should be it should have a lower latency. Now, um, say for example, you are in a car or you're driving, then these two factors, the reliability and latency, are going to be a major concern. So this type of services would have low latency, high reliability, and real-time applications. I know you probably have heard of real-time operating systems, um, which actually respond, or which they probably use in rockets and other applications like that, where you need to take the decision on a real-time basis. Like, say for example, you look at something's coming towards you and you're driving your car. It doesn't, you don't have time to compute. You have to use your steering and steer away, or otherwise you're going to hit then have an accident. So for 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 automated cars in our street, we will need to have URLLC enabled, and 5G, one of the services is going to be URLLC. So these three, that is EMBB, MMTC, and URLLC, these three are going to be some of the major services of 5G. All right, let's move to the next slide. Slicing. Just give me 1 second. Now, what exactly is slicing, or what is slicing? You probably I've been talking about slicing, and you might be wondering what exactly is slicing of the network. Now, I did mention that slicing allows the service provider to create multiple logical networks over the same physical infrastructure. Now, yeah, so now this is, imagine this is your 5G network. Now, what it basically allows you to have is a separate slice for a particular particular um, uh, separate slice of logical network for a particular application. Now imagine you have automated cars or on the streets. You can have a slice for just that automated cars. Now they will believe that the 5G network is only for them. The same way, you can have somebody who is browsing the internet. He would have a separate slice, and that slice would be independent of the URLLC slice. And the same thing with MMTC. So something like smart meters you have at home, and that would be a different slice. And also something like emergency response or the police or public safety app, so they can actually use another slice. Now each service, say URLC or MMTC, each service can have their own slice. Now when I say that, what is different? Why do you need separate slice? Now the good thing about having slices is that they're going to be independent of each other. So something happens at EMBB slice where you're browsing the internet, your URLLC slice or your V2X slice is still working. So it makes it easier for the network operator to manage when you have different slices. Not that will help fix issues, and also help them maintain issues. And slicing can be done in such a way that, if you want to create a slice and you have, say for example, there are companies here or even in India, where they do mining and they say they want their own network, and their own network in the sense that that's going to be completely dedicated to them, then we can create a slice for them. So basically, everything will be everything about that network will be managed in that slice, and that will be independent of the other slice. So the slicing, so basically, is that you're slicing the network into different services, so that each individual service can operate independent of each other. Right. Now, something about slicing here is that you are in a car and your car needs to use URLLC or ultra reliable low latency to connect, so that so that probably this is your car company. Say example, this is a Toyota car, right? And Toyota automated car. Now the Toyota car probably needs to access the application cloud for services, and that uses the URLLC line. But you are sitting inside the car and you want to watch a movie, because obviously the car is being driven by itself. Then there's nothing else you have to do. So you want to watch a movie. So then you have to use another slice, which is going to be the internet slice or the EMBB slice. So when I say that, one single UE can have up to 8 slices at the same time. So slicing allows one single UE to have up to 8 different slices. And each slice will be independent. So if your streaming might have some problem, but your URLLC would be, because this is a priority service, this would still work. So as I said, that's how it is going to work. So your network is going to be broken up into slices, and each slice would have its own priority, and it would be taken care of, and the management would be independent of each other. Right, now moving on from slices. Right, this slide is about containerization. Now I did mention that in 5G you don't have network elements like boxes which we buy from vendors. You have containers um, um, with custom applications on it. Now this slide here I will try to explain what this containerization is all about. Now, in traditional architecture, you had custom hardware sitting, and on that custom hardware, you have custom operating systems. And then on custom operating systems, you have custom applications. Now, when you say that custom hardware, custom OS, and custom applications, this is like you need to get this from a vendor. So you go to, say, Nokia, or you go to Ericsson, or you go to HP. They sell you this, and they have their custom hardware, custom operating systems, and custom applications. And every time you need to upgrade it, you need to wait for them to provide the upgrades, and then using those upgrades, you upgrade them. This is not very flexible, because you will not be able to make any changes in your applications. You will need to wait for the vendor to provide you with the updates. So it's not very flexible, and it's also costly, because you need to pay. Say, for example, I buy this, and then I already have, say 1 million subscribers in my network, but suddenly I plan to do a Christmas plan where I provide some discounts, and then my subscriber base goes from 1 million to 2 million, and then I will need to invest in hardware, and I'll need to go and buy more of these boxes. And when I say buy more of these boxes, the boxes by itself are very costly, so it's not very cost effective. And then Also, I'll need to wait for these vendors to provide these boxes, and then these boxes need to come into my exchange. I need to install these boxes in my exchange, and um, um, and it takes a long time to deploy. By the time I order for the boxes come, and I put it on my exchange, I connect it, my subscribers would be unhappy, because obviously, because the number has doubled, and the services are going to go down. So this was the traditional architecture, where you had to buy these. These were totally dependent on the vendor or the hardware vendor, and they also had these custom applications which you cannot change. It's very difficult to configure. So these were the disadvantages of traditional hardware. Now, from that, we moved to VM-based or virtual machine-based architecture. In a virtual machine-based architecture, you use COTS hardware. What is COTS? COTS are commercial off-the-shelf hardware. So basically, these are not vendor tied up. You can just go commercially and buy these hardware. And on this hardware, you install an operating system, which is called the guest operating system. Now, the guest operating system can be like a Windows or Linux operating system. Now, once you've installed the guest operating system, then you install something called the hypervisor. This hypervisor allows you to install other custom operating systems on your machine. So here you can see that there are three operating systems that I have installed. Now, each operating system can have custom applications on it. Now, since you guys are all computer application, probably most of them, you are students in computer application. You probably use a laptop or a computer. You probably run a Windows operating system. Now, search on the internet, and you will find, if you search for free hypervisor, you will find that there are softwares that you can download and install on your computer. And then once you install it on your computer, using this hypervisor, you can install a Linux or a Red Hat Linux or Ubuntu or another Windows. So this is something which you should try to do, but in a very high level, when you look at a network service provider point of view, this is actually these hardwares would be in big data centers, and then the operating systems would be usually Linux operating systems, and then on that you will have the hypervisor, and then you have the custom operating systems and the custom applications. Now here, in a VM-based architecture, you see that there is a guest operating system, which is basically on which that you have the hypervisor, but you also have to have a full-fledged custom operating system. So basically, if you have Windows installed here and using the hypervisor, this is going to be a full-flown version of Windows. But once you install the hypervisor, you can actually install a full version of Ubuntu here. Another one here, you can have a full version of Red Hat Linux. Now on this, you can have your custom application. Now it doesn't have to be one application. You can have more than one application, obviously, because you're installing a full-fledged operating system. You can have more than one custom application. And this box would be your VM1 or virtual machine 1. This will be your virtual machine 2. And, sorry. and this is your virtual machine 3. All right. So yep. These are, as you said, on the hypervisor, you are having virtual machine 1, virtual machine 2, and virtual machine 3. And each virtual machine can have more than one custom application. So if you need to run some applications which are, say, if you have installed Ubuntu here, you can have your applications that would work on Ubuntu, it can be installed here. Now, why do we need to use VM, or why do we need to use VM-based architecture? One reason is that it's flexible. So, like what you said here, if your number of users increases and you want to scale up or you want to scale down, there is no option to do that. Once you bought the machines, that's there. And if it is not using the services, then it's not using it. If it is overloaded, then you need to go and buy new ones. Whereas here, you can actually, if you don't want to use this custom OS, you can actually shut it down. You can shut down VM1, and VM2 and VM3 would do the function. So it helps you scale up and down pretty quickly and flexibly. Now, when it comes to containers, okay, I just got a notification. I just checked on the timing. I'm actually going above the time. Is that all right with everyone? Hello.
Yes, sir. It's all right.
Okay, right. I'll make it a little bit more faster. So we were talking about virtual machines now, and the virtual machines basically provides you more flexibility, and you can scale up and down pretty quickly. Now, in VM-based architecture, sorry, in the container-based architecture, sorry, this is wrong. This is incorrect. This is container-based. You have this pretty much similar, where you have COTS hardware, which is any hardware that you can buy, and then you can install a guest operating system. Usually for containers, the guest operating system is Linux. And then on top of that, what you have is called a container orchestrator. Basically, this is what manages manages your containers. Now, in containers, here you had inside these are not actually called virtual machines. These are called containers, or this would be C1, this is C2, and this is C3. Now, in each container, what you have is you will not have to download and get the full operating system. You just need to download the libraries, the binaries, and the runtime. Basically, that would be enough. And these custom applications would be microservices that is running on it. So basically, the containerization is a process where you don't have to actually have the custom operating systems installed, the whole custom operating systems installed. You just need to have the binaries, the libraries, and the runtime. Now, this makes it very, very flexible, and it actually can be scaled up and down pretty quickly. One of the examples would be that you may have noticed that sometimes when you access, say, for example, public health websites or something like that, you see that when there is more people accessing it, the site actually goes down. That's because most of the time they will be on traditional architecture. Whereas if it is in a container, you can actually bring up the container and add more containers pretty quickly. And these are extremely lightweight, and the applications can be extremely lightweight. It's that, you know, their dependency on the hardware or the compute is much less. So container-based architecture, the most important part of the container-based architecture is the containerized, the container orchestrator. Now, one of these container orchestrator is the Kubernetes. And Kubernetes is one of the container-based based orchestrators. So you can actually have a look up and see what Kubernetes is. Now, network orchestration. Now, network can be divided as I told you earlier, as a radio network, a core network, and a transport layer in between. Right now, a radio network is managed by a radio network orchestration or radio network orchestrator. Same way, a transport network is managed by a transport network orchestrator, and the core network is managed by a core network orchestrator. Now, these three, radio network orchestrator, transport network orchestrator, and core network orchestrator, is managed by something called MANO, or Management and Network Orchestration. Or basically what it does is slice management. So each slice would be managed by MANO. Moving on, this is the ETSI MANO reference architecture, where you would see that in this level, you'd see that there is a compute, a storage, and a network. This is basically the hardware, or this is where you have the hardware infrastructure. Now, on this compute, storage, and network hardware infrastructure, you have a virtualization layer. The same thing as what we spoke earlier in containerization. You have a virtualization layer. And this infrastructure, or this infrastructure is actually looked after by a virtualized infrastructure manager, or this is managed by the virtualized infrastructure manager. Now, each virtual computer or VM would have a VM function. This is VM function 1, this is VM function 2, VM function. You can have a number of VM functions. And on each VM functions, you can also have element management systems. And this VM functions are managed by VNF managers. Now, this whole thing, this would be managed by an orchestrator. And as I said you earlier, this orchestration is very important because this orchestrator would do end-to-end network management. On top of this network orchestrator sits the OSS and the BSS. Now, what is OSS and BSS? OSS is operational support system, and BSS is business support system. Right. So this is the ETSI model for MANO. ETSI is European Telecommunication System Institute, which is basically this is the model of how the orchestration happens on the network. Now, by orchestration, it means that this is what manages the whole network, or the 5G network. Right. Now, moving on. I think I've finished my slides. Probably I'll check on whether there's any questions. Does anybody have any questions?
Yes. Thank you very much, sir. It was very indeed and very informative and successful session on 5G. So participants, if you have any doubts regarding the session or related application, you can raise it now. You can even type your questions in the chat box if needed. The chat box is activated. You can leave your questions there in the chat box also.
Okay.
So you have a question?
Yep. How 5G technology will benefit future education? Right. Now, future education, right now, what happened is that when we had COVID, we couldn't go to colleges, and you had to connect via your mobile phones. You had to use that technology. 5G would enhance that. It would make it in such a way that you would be able to interact more, and you can actually have more applications that come up with 5G that would help in education. So that how would it help in the future of education? Yes, it would provide more. You can have virtual classrooms, and you can have we don't know, in future we might have we might be able to do projections, like you can actually see your teacher in front of you, or you can actually see your trainer in front of you. Next one is, how will 5G affect business? All right, depends on what business you're talking about, but definitely you would be able to use all these all the three services which I talked to you about. Something like say you have you can use a um, um, say if you have IoT devices, or if you have your devices to, if you want your devices to talk to each other and perform the activities, you can use that. So that it all depends on what your business is going to be. Do 5Gs potentially have negative impacts on environment? Okay, that's a very interesting question. 5G till now, the impact on the environment has always been the radio waves, right? And people have been having people have been raising concerns whether 5G would cause any issues, environmental issues. Till date, all the researches that has been done, they have not been able to prove that 5G or the radio 5G has got, or the radio in 5G is called new radio, and that new radio has got no impact on the environment. So but whereas when you start using COTS hardware and you're not using your traditional systems, you're basically reducing your carbon footprint. Basically, it's actually improving the environment. Will 5G developing country like India, will 5G help developing countries like India to achieve economic stability? Ah, that's a another very interesting question. Economic stability. So there has been always a thought that 5G, as you said, in the future, India is going to be a powerhouse for digital technology. Now, most of you, I would think, that believes that companies, in developing countries, um, usually hire people in India to get things done in a cheaper way. That thought is changing. When I say it's changing, what it means is that companies are not coming to India because it is cheap labor. Companies are coming to India because we have got talent. And talent always comes with a price. So when your question, economic stability, yes, you will be able to work from India. You will be able to earn more, and the companies would definitely that's going to make a big impact. What was the next one? As we know, 5G is not an incremental upgrade, but a replacement technology. What will bring more devices on board? So how can we ensure equipments and handsets are made in India so that we can help the GDP growth? Okay, right. Now, yes, what you said was correct. 5G is not an incremental upgrade, but in 4G, we have already started moving into the VM. So as I showed in my slide there with the containers, you see that we moved from traditional to VM and then VM to containers. Um, 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 yeah, it is not an incremental it is not an incremental upgrade, but it will start as being, it will not be a standalone first. The first initial solutions from 5G are going to be non-standalone, and then it would slowly replace, definitely replace 3G, and slowly replace 4G. Devices on board, how can we ensure the equipments are okay? To make sure that equipments are made and handsets or things are made in India, definitely our government will have to play that role. We will need to make sure that we have the most conducive environment, so that big companies can come in and establish their manufacturing in India. So yes, we have the talent. All we need is the will. So once we have that will from the government, then definitely we can get that, and that will definitely help in the GDP growth. And I believe we are conscious about it. So I think the government, especially the government of India and the government of different states, they are very conscious about it, and there is a good opportunity there for India. I keep hearing 5G will require millions of small cells. Why? Okay, right. So that's a very good question. 5G will require lots of mobile base stations. When I say mobile base stations, what you have in your mind is that tower in on top of your of a building there. No, that's not the base station. The base stations are going to be base stations are going to change, or your concept of base stations would change. It would be like it would probably come down to the modem that you use at home. That will become a base station. So as I said, you might be able to go to the service provider like Idea or Geo or Vodafone, and then instead of buying a mobile phone or a SIM card, you might be able to buy a base station and install it in your house. And that would be that simple. And that's why you will need millions of uh, that is why you hear that you will need a lot of base stations. And these base stations are going to be like pico cells or small cells. And they would be entirely different from what you see right now. So that's why you hear that it will require um, more base stations. Now, another thing about 5G is that when you use higher frequencies, as the frequencies in when you start using the gigahertz, um, the radio waves will not be able to travel much farther, right? So you probably know this. Your AM radio, you can hear Trivandrum in Guruvayoor, but you will not be able to hear, you probably not be able to hear FM radio from Cochin. That's because of their different frequencies. But you will also notice that AM has got lesser clarity, or it's not stereo, but sorry, AM has got lesser clarity, but FM has got stereo clarity. So basically, as your frequencies are increasing, it would have lesser penetration, so it would not go through walls or go through buildings, and that would all block it. So that is another reason why you will need um, more number of base stations. Now, any other questions? Yes, I think I've taken more time than what would have taken. So something which I can tell you is that the telecommunication technology is totally changed, and it is moved from what you call as it's moved from electronics and communication engineering to IT and computer science. Because what I talked to you about today in 5G, they're all IT, they're all computer based. They're all talking about about containers, they're talking about microservices, and these are all pieces of softwares. And that brings a lot of relevance for you guys as you are you are in computer science. So there's going to be a lot of opportunities in 5G, a lot of opportunities coming up in 5G. And when you have IoTs and different companies like Samsung, as I said, your washing machines, your microwaves, your fridges start using IoT services. And that's just one example. We haven't even scratched the surface. So there will be a lot of opportunities there. And I see there's one more question there. Will 5G smartphones support 10 GBs? Okay, right. Yes, it should. If it has that capability and that hardware, it can go up to 5 Gbps. And actually, I have actually seen it. Handsets which are specialized, right? Thank you very much. Thanks for the opportunity. I know this 5G is not something very easy to digest, but thank you for patiently hearing.
Thank you very much, sir. Since participants are not much having any doubts, and all better, we want to wind this up. I want to make a few announcements for participants. We will be posting a feedback form in the chat box right now. Within the half an hour of the webinar, you must complete it out so that we may produce certificates based on the information you provide on the feedback form. Make sure you are submitting everything correctly. The feedback link is also put there in the YouTube channel description box. So those who are attending the session through YouTube link, kindly go through the description box. Let me go on my duty to welcome Ms. Lisna Thomas, Webinar Coordinator and Assistant Professor at Department of Computer Application, to propose the vote of thanks for this wonderful session.
Thank you, Riya Miss. Respected Principal, Reverend Sister Dr. Valsa MA, our resource person, Mr. Salil Gopal, and our dear participants, a graceful and warm good afternoon to you all. It is my privilege to have been asked to propose a vote of thanks on this session. On behalf of Department of Computer Application, first of all, I extend my most sincere thanks to our dear principal sister and the management for this opportunity to conduct an international webinar. Sister is always a constant source of inspiration and support in all the endeavors of Department of Computer Applications. Thank you, sister, for the inauguration and supporting message. I extend a very hearty thanks to Mr. Salil Gopal, consultant and senior technology lead, currently working at Telstra Corp to build monitoring capabilities on the 5G network, who enrich today's webinar, Future of Telecommunication Technology with 5G in a fruitful way. The session was really productive. We are extremely fortunate to have such an eminent person, Mr. Salil Gopal, who have 14 years of experience in telecommunication industry to enlighten us. On behalf of Department of Computer Application, I express my immense gratitude to you, sir, for your invaluable talk, enrich because beautiful, lively session. Thank you, sir. I also thank our beloved coordinator, Dr. Sister Marina AA, for her guidance and moral support. Next, I would like to thank our beloved HOD, Mrs. Sabia Burgess, for her hard work and support throughout this webinar. It's my pleasure to say thanks to our dear staff members, Mrs. Ria Jacob K and Mrs. Simna Vijay, for their cooperation throughout this webinar. I extend Thanks to all the participants, especially those who are from out of this institution, for their cooperation in this webinar. I specifically thank Mr. Bush for all the technical support. Once again, we thank you for being with us this time. It has been a great pleasure. Thank you. Have a nice day.
Thank you, sir, once again. Participants, don't forget to fill the feedback form. We will generating the certificates from the feedback form, what we will submit. The certificates will be sent to a registered mail ID within shortly. Thank you. Thank you all. Have a nice day.
Thank you.